मेरे को माइक चाहिए होगा।
Morning. So I'm Abhinav. I'm currently software engineer here at Apple Labs. I'll be host for you today. So this is our 11th edition of monthly meetup. Last time we did a workshop in Pravega ISC. That was a huge success. So this meetup is about Nvidia player and the Federated Learning. And our speakers will be Nitin and Ankush. But before we move on, I would like to, tell you something about our company, our vision. So we here at Apple Labs are experts at providing service at the intersection of video processing, cloud, and embedded. So, and our vision is to, deliver the customers with the best service possible, and in a very optimized and efficient manner. So before we move on, I would like to have a icebreaker session so that we can get to know more about ourselves, the audience, and even the online audience who are present here with the YouTube stream. So can I have a So yes, I have few questions for you guys. Some easy questions, you can just answer them casually or however you want to. So can you come? And you can introduce yourself and then answer this question.
My name is Arya and I'm a freelancer and I mostly work on machine learning in AI projects. And my question is, if you could instantly become an expert in something, what would it be? Well, since my childhood I've been playing chess and I'm quite good at it. So if I could just spend 6 months of time for next and dedicate 8 hours a day, I might become very good at it.
Thank you. Okay. Why don't we invite our speakers also so that you can get to know them before the session starts? Ankush.
Hi, I'm Ankush. I'm a software engineer here. I'm also one of the speakers. So the question is, do you prefer the beach or the mountains? Why? Mountains, because I get to trek, I get to see, I get to do stargazing, and it's just more fun than the beach. Thank you.
Ankush is a very fun guy. I've been to few treks with him. So why don't you come and introduce yourself and answer this? Please come. Yeah. You can introduce yourself and then answer this question.
I'm Ajay. I work for Zebra Technology. And the question is, what's the most memorable adventure trip you have been on and what made it so unforgettable? Yeah, it was a long drive, almost 2,500 kilometers from LA to Vancouver. So yeah, that was fun. We covered it in back and forth in 4 days. So that was fun.
Can you tell us more about your experience, past experience, and your expertise?
And worked in product development mostly, software, databases, middleware, and currently working in machine learning.
Nitin, please come.
Hi guys, I am Nitin Sagar, working as software engineer at Apple Labs since 3 years. I mostly work on
various products or and friends. I like football. Any day you can ask about football. I'm ready to help. The question is, what's one thing on your bucket list that you haven't done yet? So again, it comes to football. Many of you may be knowing about Santiago Bernabeu, the Real Madrid home stadium. So I want to visit that stadium once in a while. So that's the one thing in my bucket list.
Thanks, Anil. We share the same bucket list. Yeah. So I think we all know each other. So I think we can start with the session. Ankush, please come.
Hi. So these are the same things on our agenda. Traditional machine learning. We'll talk about how traditional machine learning is done and what's different about federated learning, and we'll see what is federated learning and how does federated learning work. It's internals, and as all things, it has types, benefits, and its limitations, and Nitin will share more about its applications because he uses Nvidia Flare SDK, and we'll share about the high-level system architecture of Nvidia Flare, and we'll see the different ways to run Nvidia Flare, and of course he'll show our demo. So like you already mentioned, you work as a freelancer in ML,
Yes.
and I think ML is like the hot topic right now. Like it has been for a few years. So we know that traditional ML algorithms use a lot of data. So that's the general traditional machine learning application where you gather a bunch of data, put them in your data centers, and then train them. But the problem is that you actually have to get the data to your data center, and that poses risks of security and privacy. So federated learning tries to solve these issues, and I think the way to think about federated learning is like the word federal. You know, like we think about like sort of central and state, like in political system. Like you have states have some power, and then federal have some power, and then you sort of the governance system is sort of federated. So like you distribute it. So that's the way to think about federated learning, where you distribute the learning process. So like that's the way to think about federated learning. So yeah, now my colleague Nitin will share more.
Thanks, Ankush, for the start. So let's go into more in what is federated learning and its examples, applications, and everything. To understand on a brief, like you have data present on different machines. You have like IoT hubs, everything present. You have that data on present, but it is your privacy to keep that data secure. So federated learning helps it is a machine learning technique where your data resides on your own system and you train models out of it, and there is one global model. There is one global model which is being trained on your own residing data. Just to understand it more, we'll go like how federated learning basically works. So as you see, there are three sources of data coming from three multiple places. Like one is community hospital, another is research medical center, third one is cancer treatment center. Their own organization, they have their own private data basically, but they are kind of similar because patient. Either you go to the community hospital, research medical center, patients come into picture. But these organizations don't want to share their data with anyone due to regulatory things, NDPRs and GDPRs. So what will we do with that residing data present in those private hospitals and etc.? We have to come up with something. So using that data, we can train the local models on their residing system and give those results or outputs back to the global model. So federated learning helps in this manner, where you have a global model present. You will pass out that global model to all the residing states. Like, it will train all the local models over there. It will keep the data private. It will make it secure enough so that not only the data gets passed to the global model, only the outputs or the scores which have been trained have been passed to the global model. So this is one such example where you see 3 different sources giving back to the federated learning approach. We have different types of federated learning, basically horizontal federated learning and vertical federated learning. Horizontal, you can think of in terms of healthcare industries, where you have different same features. Basically, you go to different hospitals, you will store the same patient data with respect to one disease. You have to like, according to the standards of the disease being cured, you have to capture some of the same features. So you have the same features in multiple organizations but different samples. So horizontal federated learning helps in this example. Vertical federated learning can be talked about like you have different type of set of individuals present over it. Example is financial services. Financial services, I'll give you an example with respect to finance organization and a retail commerce organization. So because financial will have only the transaction, but the retail industry will have what you use those transactions for. So you can merge both of this and train a model out of it, like how the user is using the transaction for a particular retail thing. So this is kind of a vertical federated learning. Next, we will go into benefits of federated learning. So as we are talking about, main thing is the data privacy and security. As I've already told that data resides on your own system, that is not going to go anywhere. Only just the model, whatever you are going to train, will be present on that system. So privacy, security comes into picture, and you don't have any data breaches as such. As I already said, we have adherence to regulatory compliance, where we have our own GDPRs and all those things. So with the help of federated learning, that also makes regulatory. Next is the increased bandwidth efficiency. So if you have large amount of data and you want to train it on a global server model, you have to transfer all that data to a global server model. But here, as you are sending only the models to those clients, and your bandwidth efficiency decreases, because you don't have to send the complete data, just you have to send the model outputs as such. Last, we have a greater scalability. Like, we can use these things on multiple devices and networks from like wide range of applications, from mobile application to IoT devices. When we go to the application, I will tell you one of the IoT solutions which will help make more scalable. When it comes to some application, there are some limitations also. With respect to the limitation, we have data heterogeneity. There are numerous devices which are coming into picture. We have independent and like unbalanced data sets. All of them maybe not capturing the same data set, so we have a different data heterogeneity. Next, Next point is with respect to computational constraints. Computational constraints is like not all organizations are uh, may have limited computational power and all. So if you speak like all states, all countries may not have the same infrastructure as everyone. So and maybe their devices also with less computational power. When we go next to our limitations, we have model and system complexity. So when we are talking about federated learning, main thing is the model, and that model depends on how complex your model is and how can it behave when it goes to different clients and all. So this is with respect to one of the limitations of federated learning. Applications, I already spoke about healthcare and finance, where in terms of healthcare we have multiple sources like community hospitals or government organizations and all. With respect to finance, we have like finding out anomalies and all those things. With respect to autonomous vehicles, I think it will help in terms of traffics and all, where your data, your location and all resides on your vehicles itself, and you get a better experience with respect to the experience. Okay, so autonomous vehicles is one of the applications of federated learning. As we have come across now, understood some basics of federated learning, we'll more into our main topic, which is Nvidia Flare, and what Nvidia Flare provides so that we can do the federated learning concept. So Nvidia Flare is an open source SDK provided by Nvidia, which was open source in 2022. It basically has several APIs and all the features which federated learning requires. So we move on to the high level system architecture, what basically we want, what it provides. Starting from the bottom, main thing is the communication and messaging. We are saying about we will decide the data on different systems. We have a server, we want to talk that server to those clients, and main thing comes into the picture is the foundational layer called as communication and messaging. On top of that, we have different workflows kind of thing, which will help to run different algorithms. And Nvidia Flare also provides APIs to transition between those states. So one more thing comes into picture is privacy and security. So privacy security, they have taken different approaches like differential privacy, harmonic encryption as such. So I'll explain more in details in the further slide, but just to give the overall high-level system architecture. And then when it comes to deployment, they have different tools with respect to local as well as production. When it comes to local deployment, they have simulators. It kind of simulates your environment of federated learning in one system, and proof of concept with respect to development. When it comes to production, they have different tools with basically provision, monitoring and orchestration. We will go more into this tools and all in the further slide. As I told, the foundational layer of federated learning with respect to NVFlare is the communication. Let me help with the example where we have one server and multiple clients, basically 3 clients, and we'll keep that admin aside for some time and look as our main focus is on the clients where all the data resides. And coming into the picture, the security is the most concerned thing. Client has all the data which should not be transferred to the server. So what connection it does, communication it does between the server and client is the gRPC which was developed open source by Google, which is remote procedure call control. So what it is based on HTTP2, and what exactly it does is like it uses the remote procedure call as the underlying architecture and transfers only some data out of it to the underlying host system. Internally, what it does is like whatever training outputs or model outputs you expect, they are passed through some messaging format which is sent back to the server. Another role of the admin is to administrate all of the server and client scenarios, and to communicate between admin and the server there is a TCP connection, which is, I think everyone knows, which is the best suitable protocol. As you see, the admin can only talk to the server and not through the client, so it doesn't have any control over the client, and it helps only to administrate the jobs between the server and the client. So this is how the communication goes into picture. As I've talking about the communication thing, next we will go into the actual workflow, how the federated learning workflow comes into picture. Example is on the left side we have a server and a client. So the main two things come into picture with respect to the workflow are controller and the worker. Controller is kind of it has a pre-processing steps where you get a task from a worker, assign the task to the worker, the controller assigns the task, and it has limited data present on to the client. So it will execute those specific tasks on the client and return back the result. I'll explain it more better with respect to the scatter and gather workflow. So with respect to scatter and gather workflow, what happens is like there is a global model present on your server, and client has its own residing data. You scatter your model into multiple client systems, and the client basically validates the global model and trains on their data. Client basically trains on that data and send back the model, trained local model to the server. Then the server aggregates it on its own and send back again the updates to the client. So what exactly happens? This repeats for a number of rounds until you find a particular expected global model output. To evaluate also, they have cross-site model evaluation. What exactly this does is like whatever your model is being trained on your local system, and whatever global output model is there, it can be evaluated using these workflows. Basically, cross-site model evaluation. When it comes to workflows, we spoke about the scatter and gather workflow. With respect to scatter and gather workflow, the algorithm being used is federated averaging. And I also gave you an example where the client runs its local model, then sends back the data back to the server and it aggregates. The federated averaging does the same thing. Aggregates model updated from the multiple client and creates a global model out of it. Next, we may have heterogeneous data present into the multiple clients. So next algorithm being used is the federated proxy. So what it adds to the averaging is like a loss function or a noise which makes the global model output better. So this is how federated proxy helps with respect to the whatever global model output we present. Next, we have the optimization things also. Whatever model which has been trained from the optimization after the averaging and all has to be optimized. So federated optimization helps with respect to that. There are different SDC variants which help us to do the optimization. The main concern with respect to us is like privacy and security, and also Nvidia Player provides those, considers those as most major things, and they have these privacy and security concerns. So with respect to identity and security, anyone who is participating has to be authenticated and authorized. So server can't basically, even if he authenticates, he can't access all the data. He has to be authorized to get some of the data which is residing on the server. So they have SSL certificated kind of scenario where you connect with the client system, and which will help you to authorize your existence. Every site, next comes into picture is the site policy management. Every site has its own set of rules and policies, and which has to be regulated. So site policy management has to be followed. Next is communications security. We are saying that global model output will get the client output, but what if it is being breached in between? So communication security helps in with respect to whatever participants are giving out the output are being encrypted and so. So this will help us with respect to the communication security. Finally is the message serialization. We are talking about the machine learning model, so the whatever output model can be complex. So message serialization will help whatever is being transmitting over the network is deserialized and is easily transmitted and deserialized. So this will help, message serialization will help in terms of this feature. As in the high level architecture I already showed, there are some APIs present to run the Nvidia Player across multiple systems. Here we see those APIs present. We have a provisioning API, the server API, the admin API, and the client API. So here the example is where you have one server and it is talking to 3 other clients, and you have one admin portal. So what this provisioning tool API will provide is a startup kit, which I'll be showing in the demo, where you write a YAML, basically a format where you tell you want to connect to three clients. You have one server and one admin which will be administrating. So provisioning tool will help us to create those startup kits and which can be distributed across multiple clients. Admin's API over here is to control only the required set of tasks or list the jobs basically. So whatever communication is happening between server and the client, admin will have a complete control over it. And at the end, client's APIs are only whatever server task has been executed by the server has to be approached and done through the client. So they have their own event like tasks and events which should be performed. So these are the APIs. Yeah, these are the brief explanation with respect to each API. When we go set up Nvidia Player into our local system, there are different ways to run Nvidia Player. The setup process is very easy. You can use Python or use Docker network basically. with the help of Docker also you can set up Nvidia Flare. They have their own ways. When ways to run Nvidia Flare is like there are three different ways. One is simulator where you have where you want to run on a single machine where you use different threads to run different clients. POC is like a proof of concept. It is also on one machine, but here it uses different processes or different Docker instances. With respect to the production mode, this mode is more secure for training models for production, and it is kind of distributed fashion. I will be showing a demo on how to run a federated learning machine on production using production mode in my demo. So let's go to the demo. I can talk about the references. These are the official documentation present for Nvidia Flare. They have their own repo on GitHub, which is open source, and these are the references which you can help run Nvidia. I'll show the demo. Let's consider my left machine is acting as a server, and right machine is acting as a client. So all my is it fine? Is it visible? This is. Now.
So that is ideal.
Yeah, just to resume, if the Docker gets run on the client machine, as I already said that we can install Nvidia Flare using pip or writing the same steps into a Docker building a Docker image out of it. So what I've done is to simplify is that I've run Nvidia floor on both of the systems, and these are two different systems where one is a Windows system and another is also Windows system, but it's a different new. So I want to show like a server being connected to a client where the client resides. Client has some data. We will create a machine learning job, basically a XGBoost gradient job on the server machine, and submit that job to the client and try to run the model basically. So as the Nvidia, the main server machine has started, and we will initially see how to connect between two systems. And I already told about the provisioning step in the API thing. So what exactly provisioning means is like you have
they already have. And then we have this icebreaker thing where you pick one of the question and answer it.
Some time to think about this.
Okay, time. Do you want me to choose another question?
No, it's not hard. Actually, quite something. Sorry, repeat the question. My name is Ritu. I have recently joined Philosophy AI as a software developer. Earlier, I was working as a content developer for a few months, and now I got the tech role. So the question is, if you could have dinner with any three people, dead or alive, who would they be? So my answer is one can be Albert Einstein, because he was a very good thinker and he could explore a lot of ways in different dimensions. And second will be my personal kind of thing, my mom. And third, I was not getting close to.
Because what I was
Can I know something like on you always?
yeah, I think we have a speaker, Nitin and Ankush. Ankush, can you come and again tell about yourself, your hobbies?
Hobbies?
Yeah, he loves trekking. That's one thing.
I love trekking.
Which is your favorite?
I have been to only one reason, that was with Madhya Pradesh. It was 3 years. 3 years.
I've done Bengaluru.
Where is it?
It's from Rishikesh. I'm Ankush. I'm a software engineer here. I'm one of the speakers. I work as a backend developer, like my background is computer vision and machine learning. But right now I'm working as a core software engineer. I work on multiple stacks, like C++, Node. Like speaking of stacks, like we have a lot of stacks here. We had a graph where we had all the stacks in the company and.
To summarize, we here at Apple Labs are experts in the intersection of cloud, video processing, and embedded.
Yeah.
So we call us a software developer, but we are kind of computer vision engineers, the 3D graphic designers, everything. Yes, and that.
I think most of them are from here.
Yeah, I mean, this is our technical team, and then this is software artists. So why don't you come introduce us?
So myself Dinesh, so I'm working as a process specialist in Mr. Copper. It's a mortgage industry actually. So I want to switch into IT. That's it.
So yeah, these questions are not breaking ice.
Similar question. The question is that fun fact about myself that many people know. Not many people know. Like actually I'm a extrovert, so many people know about me. So I don't think this answer for me. Yes, thank you.
Would you like to share something about you?
What me?
Yeah, some fun facts, because we don't know you.
Yeah. Like in the sense, what question?
I think it's possible.
Like I'm like I would like to call me as a tech enthusiast. Like I would like learn my thing is that I want to know everything. Like even at least the basics or anything. Like I just want to know everything which exists or something. Just a curious person. Thank you.
Do you want to introduce yourself? We as a company.
Okay, hi everyone. I work at Agra Labs as a software developer. I have an experience of 3 years, and I mainly work on the front end side, React. And yeah, my hobbies are basically going out, exploring new places, and some days we just lazy around and in weekend and chill. So yeah. Okay, I'll pick up at you guys.
Yeah.
Do you have any hobbies or interests outside of work? Yeah.
Directly interacting, like in case of software related to airport security and that which requires really low latency and you don't want it to break because there is no
100. Theoretically, even if the
That's what.
he got to think the most for the
Over time.
it is good to
So we'll continue the demo of online, and for now we'll continue with snacks.